All right, starting off lesson 5.4, solving special systems of linear equations. All right, what do they mean by special? All right, we'll see what they mean by that in a moment. Okay, so we're used to this situation where if you were to graph a system of equations and they intersected, your solution would be whatever that point is, okay? And we've figured that out when we've worked with substitution and elimination. We've figured that out algebraically. Now, there are situations where the lines don't cross, all right? That's when the lines are parallel, or the lines actually overlap. It's essentially the same line. So if you're solving algebraically, what actually takes place when working out that problem that indicates there's no solution, or that there are infinitely many solutions? All right, let's look into that now. All right, so example 1, solve the system of linear equations. Okay. You have all these different methods. We could graph, we could use substitution, we could use elimination. I'm going to use substitution in this case, since I already have y isolated. I'll plug the 2x plus 1 into y in the other equation. So I have 2x plus 1 equals 2x minus 5. All right, then I'll subtract 2x, cancels out, I get 1 equals negative 5. Okay, so with the situation we're in right now, the variable's gone, we're left with an equation or equality that is not true. All right, if it's not true, then that means there's no solution to the system. Okay, it's as simple as that. Let's do another example. Solve the system of linear equations. Okay, let's do some elimination here. I'm going to multiply top and bottom here by -2, so the x's cancel out. So I end up with, got to distribute here, be careful with that. I end up with 4x minus 2y equals -6. I have -4x plus 2y equals 6. All right, so the x's cancel out. Oh, well, so do the y's in this case. I have 0 on the left side, and on the right side I have 0. So all the variables cancel out, and I'm left with this equation where it shows that 0 is equal to 0. Is that true? Yes, it's true. And if that is the case, that means you have infinitely many solutions. All right, so it doesn't matter what numbers you plug in for x and y. All right, there are infinitely many solutions. Well, actually, it does matter. X and y go together. Okay, but there are infinitely many solutions. All right, example 3, modeling with mathematics. The perimeter of the trapezoidal piece of land is 48 kilometers. Okay, the perimeter of the rectangular piece of land is 144 kilometers. Write and solve a system of linear equations to find the values of x and y. Okay, cool. So here's my trapezoid, and perimeter is just adding up all the side lengths. So I have 6y plus 2x plus 6y plus 4x, and it tells me that all those together should add up to 48. All right. So simplifying this, I get 12y, I get plus 6x equals 48. Then I have this one here, I have 9x plus 18y plus 9x plus 18y is equal to 144. All right, I'm going to put the y's first and the x's second. So I get 36y plus 18x is equal to 144. Okay, so I have these two equations to work with now. Let's line them up. So I have 12y plus 6x equals 48. All right, now I'm going to solve this system by elimination. So I'll multiply this equation by -3, top and bottom. Not top and bottom, I mean left and right. Don't forget to distribute. So I end up with, I'm going to have the first equation here. I'm just rewriting it. Didn't change anything. All right, this is the next equation that I multiplied by -3 on both sides. Okay, what happens here? Y's cancel out. X's also cancel out, so I have 0 on the left side. And on the right side, I have 0 as well, once again. So this is a true equality. And if that's the case, then there are infinitely many solutions. All right, there are infinitely many pairings of x and y's that will satisfy this system. All right, that's all there is to it. If you have any questions, please let me know. Begin the assignment at the bottom of the webpage.